Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to this latest episode of the Trend Detection Podcast. I'm really pleased, and today we've got a new person on the podcast, a new person to interview, which is always very exciting for me. It's actually my colleague Maria. And today we're talking about predictive maintenance, funnily enough, but we're actually talking about some of the buzzwords that sort of surround predictive maintenance. Predictive maintenance itself is a buzzword, you might say, but there's so many different topics on the outskirts and some that are very, very important and closely related to that predictive maintenance topic. So before we sort of go ahead, I'll just hand over to Maria just to introduce yourself. So over to you, Maria.
Thanks for having me in the podcast. So yes, my name is Maria Thoms. I've worked for Siemens for a little bit more than 2 years now, and I've come around the topics of predictive maintenance quite early when I was studying. So I was studying information systems, and a lot of those topics and a lot of those buzzwords circling around predictive maintenance are actually also covered in those basic studies when you learn about AI for the first time, trying to understand what it all means, and now also putting it into practice to really learn about those buzzwords in action, what it means when it comes to the customers is really, for me, very interesting. So I'm happy to be here. Thanks for having me.
Excellent, and hopefully you'll enjoy it enough to want to come back. But I'll ask that question at the end. At the end. So let's get started. Predictive maintenance is the obvious place to start. And I've seen, I've been with Senseye, now Siemens, for the past 4 years, and I've seen that the term just pop up everywhere. Everything's been labelled predictive maintenance. Do you think, first of all, do you think predictive maintenance is sort of an overused term in the market, like it's being applied in the wrong way, let's say?
100%. It's funny sometimes how you talk about predictive maintenance for about 10 minutes, and then you realize you're not really talking about predictive maintenance so far. So there's those different stages, I'd say, where predictive maintenance is used as a term for actually 4 to 5 different things that we're actually discussing, especially when it comes to customers that have never heard of digitalization or at the very beginning of digitalization. It's very interesting to see how they really want to tackle the challenge of, hey, let's get some insights into our data, let's get some AI, let's get some learning, and you really discuss about very basic topics in the beginning before you even start with predictive maintenance.
Yes. So what? I guess that's a good place to start. So what are those stages, and do you see them as part of predictive maintenance, or sort of linked to predictive maintenance, or how would you put it, Maria?
So I would say the very basic start, or where most companies are at the moment when we talk about predictive maintenance for the first time, they're actually more in the phase of preventive maintenance. So what does preventive maintenance mean? That's basically if you have a fixed schedule for maintenance, where you say, okay, let's have this equipment checked every month. Let's have this and that part exchanged every month, because we know from experience, from expert knowledge, that this is probably going to break after 6 months or whatsoever, whatever guarantee or maintenance management says. So that's the preventive maintenance topic where many companies are at the moment. And the difference to predictive maintenance, and this is where all those beautiful buzzwords like artificial intelligence, big data come into play. Predictive maintenance, in contrary, is really trying to detect from data to see, hey, how does the equipment really behave? What is the condition of the equipment? Let's try to predict when the maintenance should be performed instead of having a fixed schedule, rather than waiting for equipment to fail. That's basically the difference that you have.
Then I guess if we compare that, a lot of people instantly compare that to condition monitoring. So, people say, oh, we're monitoring our machines, we're collecting data. So what's the sort of differences between condition monitoring and predictive maintenance?
It's a very, very good question. I would say condition monitoring is more an enabling factor for predictive maintenance. So, for example, if you know, hey, I'm efficiently monitoring the condition of my machines, the condition of my equipment to detect any changes or deterioration from what we think is normal. That's information that comes out of the condition monitoring as an action or as in practice that you can then use for predictive maintenance. You can think of it as condition monitoring being delivering the data they can use, and predictive maintenance actually being the algorithm trying to understand the data and trying to derive knowledge out of the data that you feed into.
Yeah, so it's sort of entry level. I guess it's like laying the groundwork for predictive maintenance, right?
Exactly. So there's a good example that most of people understand it in a very easy way. For example, if you want, like many people have something like a smartwatch, and what do we actually want to achieve with that? Our human body is quite complex, but in some terms, it's quite easy for us to understand if there's some changes or good or bad things. For example, let's take the heart rate. If you know what your heart rate is and you know this like from measuring the heart rate, then you can derive some knowledge out of that. For example, if you know your average heart rate is like around 60 or 70 beats per minute, and suddenly your smartwatch detects, hey, you are having a heart rate of 100 or 120 at the moment, you know just from knowing that there's something different at the moment. Maybe let's say 120 is not that, it's not that bad. It sounds like you have done some activity because you know. You might have some, I don't know, you've probably gone some stairs or you've walked for a mile. But as soon as the heart rate, or as soon as your smartwatch detects a heart rate of 200, you might be wondering what happened. And so these are small indicators, and this where the smartwatch is actually con- condition monitoring in a very easy example. You say, okay, let's start very basic. If you didn't have the smartwatch, let's start at the very basic example. And you just want to improve your, let's say, you want to improve your running. You start from zero, and you say, okay, let's start with some heart rate tracking because that might be an indicator of it. And you could go ahead and measure your own heart rate manually every, I don't know, 1 minute, and then put your measurement into an Excel sheet. And you might give that a structure and then have an Excel sheet for each day and for each month, and you can maybe calculate an average, but there's a lot of manual work. And this is probably a very good indicator of manual work that's not really efficient. And this is where the smartwatch comes into play, saying, hey, okay, this thing can actually measure automatically, and it just measures by doing it on a frequent basis. I think if you the most common smartwatches, they just measure your heart rate every minute or every 5 minutes, and it actually just collects data from your human body, and it knows, hey, okay, you've had a heart rate of on average of about 80 for the past couple of hours now. So you're probably not doing any activity, or so on. And probably for those people having a smartwatch, once you go for a run or you start doing something and your watch is going to tell you, hey, it looks like you are doing some activity, and you're like, oh yes, I just started jogging. So how does this smartwatch detect that you're doing something different? It actually automatically again collects your heart rate and detects a difference in what is normal. Actually, those changes in deterioration. This is exactly what condition monitoring is. It just basically measures your condition being the heart rate, and monitors what you're doing, and it actually detects there's a difference, there's a change, and this is the basics of condition monitoring. When it like speaking in very daily terms. And now, what's the difference to predictive maintenance? What a smartwatch would do if you would be running for hours now, or at a very high speed, it would detect that your heart rate probably goes up quite fast, quite high. And it can send you an information saying, hey, I think if you keep on running in that speed, your heart is going to explode. That's not what the watch is going to tell you. But but actually, a good example is also those noise detections. If you've been listening to music for quite some while and your phone is giving you a message saying, hey, um, you've been listening to music for quite a while now, please turn down the volume, otherwise your ears are going to explode, or your ears are going to have, I think it even says your ears are going to have failure. And that's actually predictive maintenance in practice, in a very daily example that people are experiencing.
Yeah, it's interesting. don't actually think of that, but you're right. It's a very very good example. Very good example to give. I guess the other thing that, and I guess we can talk about AI as well, but I'm also hearing that watches are now sort of not predictably, they're giving schedules out, based on your health, fitness, and stuff. They say, oh, we think you should do 20 minutes of this, 20 minutes of running today, would, based on your stress levels, based on your fitness levels, based on your sleep, etc. And I guess it's AI calculating that as well. So, and again, I guess that's a form of prediction, isn't it? We think, this is the symptom we see, and this is what we think can help, resolve it.
Exactly. And like how AI, so artificial intelligence, comes into play here, it's actually using the data that you're collecting on a daily basis, and actually identifies patterns. And this patterns is the term that you're also referencing to when you're talking about, hey, the algorithm kind of knows that you've been doing this for quite some time now, or you should be doing this because this and that. And this is basic, let's say, mathematical algorithms. And they really are focusing on if this and this, then that and that happened in the past. So they learn from all those if then statements, now really speaking in technical terms, if you've done this, if and then for 10 times out of 10 times, then that's probably a pattern that you're using that has been good in the past for you, or that has had some positive impact. So AI is actually just using the data and the patterns to make predictions about the future. So there's different, I would say there's different algorithms in place, and usually when we are talking about artificial intelligence, we're kind of classifying those algorithms into four different areas, I'd say. And most of the areas are quite well known to most of us. Let's just give it some examples. Very easy example is actually this decision making. So when we talk about decision making, that's a very basic human task the human brain is doing nearly every second. And the fun thing about artificial intelligence is actually, what does it mean? It means that we are teaching a computer or a program to actually just do human brain tasks. That's all we do. And one of these tasks is decision making. So, for example, if you have a look outside and you see, oh, it's raining, you decide, I'm going to take an umbrella with me. And if you go outside and it's not raining, you decide, I'm not going to take an umbrella with me. Easy decision making. So, an algorithm would do nothing else and collect the data of the past, I don't know, 10 days, say, okay, it hasn't been raining for 8 days. There's been 2 days of rain. What's the probability that it's going to rain today? Oh, it's quite low. So let's decide to not take an umbrella. That's this basic decision-making task that we have with AI. Another like application that we're using is communication. So that's basically what human beings are doing on a daily basis, 24/7. We are communicating, and the main task here, for example, if you talk about voice assistants, they are also just using communication. If you tell your voice assistant to do something, they just take the words that you've been saying, try to find some structure in the words, try to find a sentence or a meaning of it, and try to do the right thing. That's also what humans do. If we talk to someone and someone is telling us to do something, we're trying to derive what is the person actually telling me. And most of the cases, I would say, we're understanding it the right way, not 100% of the cases. And the same counts for communication algorithms. So if a voice assistant is doing something totally wrong than you told them to do, most of the times it just didn't really understand or figure out what your words and your sentence were supposed to mean. And there's easy things like play this and this song. It's quite easy. Play, okay, that's an action I need to take. A song, I can find it somewhere. That's an easy thing to do. But as soon as you start giving them complex tasks, and it's maybe a funny example, even tasks that might seem very easy for the human brain are very hard for AI algorithms to decide. Let me give an example. This you could give this to an AI algorithm, they wouldn't know the answer probably. Let's say John has three brothers. Small, big, and medium. How is the fourth brother called? And the AI algorithm will be like, I don't know, I don't have the information. And the human brain will be like, obviously, it's John. But this kind of deriving information that's actually given, but not in the way that the algorithm is understanding it, actually makes it quite hard for them to understand.
No, I guess just on that as well. Like, how do the two sort of play together? Because you mentioned the impact of the human and the impact of AI. How can they sort of work together? You know, again in this sort of industrial setting, as in predictive maintenance related.
That's a very good question. So in in practice, so in industrial terms, we are kind of using the term Internet of Things, so IoT, saying we have a network of connected devices, and these actually collect and exchange data. It's like human brains exchanging data by communicating, by doing something together. This is what IoT devices do in the field. So, for example, we're talking about sensors. They just collect the data from whatever equipment they're connected to, and these data, these insights from those connected devices are the ones that we then use for data analytics or even predictive insights.
And that makes, and then when we bring in, because I guess the you know the latest buzzword, I don't think it was in our list of questions. I don't know why, but sort of generative AI is now becoming, and a lot of the customers you speak to are now hearing this term. And again, it's maybe too early, but already people are forming their own opinions of it in their heads. I mean, what's your sort of view on that, based on what you were sort of just describing just then?
I would say generative AI actually builds the bridge between AI algorithms and the users actually using it. So if you actually are given the chance to just ask your tool or your algorithm to answer the question that you actually have been asking, that you probably would have asked a maintenance manager before or a service technician, and you actually get the exact answer that you are asking from a algorithm, can be very, I'd say, scary at the beginning. But if you realize the value of it, the value of, hey, I can ask a question, then an algorithm is answering with a full blown set of data collected, with all the information that is there. So, all the information of many, let's say, human brains just stored in one place. And I can ask that question, communicating that question as a human, that the way I would act, anyways, and derive the knowledge or the answer that I'm expecting to hear. I think that's actually a very, very good step towards the usage and towards the value of AI in practice.
And I guess just a general point on AI, is it something that I say customers and people you speak to, outside of Siemens, I mean, do they understand it? Do they find it a scary thing? Do they find it an exciting thing? What's your sort of view on that?
That's very interesting. And from my experience, most people just see it as a buzzword first and are
Mm.
not really have the full understanding of what it means. They just know it's all around. It's kind of important. It's new, but it's not that new anymore. And this is why I also like to just explain the basic terms of it, just to get some to make it more easy understandable, because it's actually not that complex. Not everybody needs to understand the deepest depth of those mathematical algorithms lying behind it or underneath it. But I also see that some people tend to like not. They say sometimes people say, "Hey, I don't understand what AI is doing, so I don't know what to do with it." And to actually close this gap, and this is again where generative AI comes into play, to make it more easily usable, because it is there. AI is there all over the place, all over the world, especially also now in the industrial areas. And to see the real benefit and value of it, that's the only thing that I would love people to see and realize. Not everybody has to understand it in the whole depth of it. But that's also the encouragement I can also give to people. Try to be open to it. Try to understand the basics, being communication, being decision making, all those things the human brain is doing. And yeah, make use of it in a simple and easy use case first before you, I don't know, analyze your full factory or something like that. Try to understand one machine first, and then see how machine learning or AI can actually get yourself into understanding the machine better than ever before.
Yeah, and I think what you said at the start is really true because and it's something Senseye's been on this journey as well. Being an AI sort of based tool is that you don't need to focus on the AI. I mean, we could have our sales pitch could have been, oh, we've got this great AI. It's really cool. It does this, this, and this. But actually, what we found is people, what people really care about is how it's going to, the business outcomes. What business outcomes is this tool going to help deliver? And I always compare it to something like an iPhone, where you don't care about how it's working in the background and what happens and what gets it to do the amazing things that it does, but all you care about is that it's easy to use. You can contact people. You can go on all the apps. There are other smartphones available, I should say, but just because I've got an iPhone. But yeah, I find it similar to that, where you don't need to know the mechanics behind it. I mean, if you're interested, then great, but it shouldn't. In some ways, it shouldn't form part of the decision process. Let's say that's what I would say anyway.
Exactly, and also putting it into practice, and that's what I really like about Senseye Predictive Maintenance, and in particular, those messages that you get sent, those cases raised, for example, in Senseye, when they say, hey, we detected an deterioration from the normal, an anomaly in this and that machine. This could be due to this and that. Go ahead and do that and that action. That's actually great. It's actually, you do need to understand why exactly now this case has been raised, but actually you can just go ahead and take action. It actually makes you so much faster to get to the action that needs to be taken in order to prevent equipment failure, for example, in order to prevent the downtime, because you just know from one site, from one click, what needs to be done. And that actually saves in practice, like when you're really at the machine, at the facility, at the site, and okay, I need to take action immediately. And you just know, if you're a maintenance manager, for example, or a facility manager, site manager, whatever, and you just know, okay, I have to go to that person, tell them this and this needs to be fixed, and then the problem is solved. It actually saves you so much time, stress, gray hair. So that's actually the advantage that I would love the customers to see.
No, exactly. No, 100% agree with that. I guess one area we haven't covered in depth yet, and is quite an important part of the picture, is data. And data's a broad subject. I mean, IoT, Industry 4.0, whatever you sort of want to call it. But again, I know Industry 4.0 is like the buzzword. I'm going to say it's almost like the ultimate buzzword. I've found, because it can mean so many different things to so many different people. So maybe we could start there, Maria, with Industry 4.0. What is it? Where are we with it? And are we at 5.0 yet? Which is probably at every industry event you go to. Well, you see that title. But,
It's very good. I feel like when I started at university, Industry 4.0 was already there, but in a totally different way than it is now. So I would even bring another buzzword in, which is big data. And big data is actually the reason we turned into Industry 4.0, or why we're doing that. Because in this mix of, let's say, digital and a non-digital world, we have a big gap between the, like, what data is there and what data we know and understand and derive value out. And this is actually where this term big data comes into play. We have a lot of data that is being created on a day-to-day, minute-to-minute basis. And there's so much data from various sources, also including those IoT sensors, very specifically when you're talking about any machines or facilities. And within the customer sites, there's so many things that create data from so many different sources, and that's the big data topic. And now, and this is where Industry 4.0 comes into play, companies started to try getting insights into the data, because we realized there is a lot happening and we can understand it by trying to digitize it or digitalize it even further. So that's kind of the big change between Industry 4.0 that came into play with that, to not only have the data available, let's say on the field level, but also in the outer level, in the IT level, in the cloud areas. How can I make someone aware of a machine failure that's not even there physically? So that's the big change that came into play. And this is actually what also enables companies to get more efficient with their resources, for example. If not, every time there's something going on within the facility, there needs to be someone actually going on site, but you can have analytics from far away. You can consolidate knowledge in, for example, knowledge centers. And this is what really brought a very new side into, I would say, this whole industry area with Industry 4.0.
Yep, I guess that area you're sort of going into there is this sort of cloud versus on-premise, which again is a buzzwords we've not added to the list, but cloud certainly is, and it's probably something that everyone's sort of heard. But what sort of differences between the two, I guess, for someone who's not in the know?
There's also a very, very good and interesting question that I also always try to answer with a very easily understandable example. For example, if you think about where your money is stored, do you have all your money like underneath your pillow? Or do you have it stored somewhere else? And this is basically what's the difference between on-premise and cloud. If you had all your money stored below your pillow, then you would have it on-premise. You would always have it accessible, and nobody all over the world could access it. So it's very safe and secure. But and that's the big but. You always have it. You have it on your side only. You cannot just I don't know, if someone's asking you to send some money, you would have to, I don't know what to do with it. So, and that's the difference with cloud. Actually, cloud, the definition of it would say it means that you have your assets or your data stored in someone else's storage. That's the mere definition of it. And the same accounts for your money. You actually have your money, well, you probably have your money stored in someone else's, be the bank's storage. And it's actually a very digital money that we're using at the moment, or in nowadays. It's a big difference, and I think also in the beginning of money being in the cloud, it was very scary for people to just put their money in a bank account and not having any access to it. But I think also people got used to that. I'm quite sure that people got used to that. And the same accounts for our industry when it comes to cloud. Of course, it has a lot of advantages to have your data on premise, especially when it comes to high frequency data. So that's the topics that always speak in favor of on site. But if you talk about cloud, accessibility, IT security, cybersecurity, all those topics are actually put on a very different level when we're talking about cloud storage of data.
And I really like your sort of comparisons you make, Maria, both that one and the ones you've talked about already. It's a really good way to sort of position it. I guess the other thing with cloud as well is sort of the scalability factor as well. And that again makes sense, because if you're keeping your money under your pillow in your house and you want to share that data, data with money in that case, I'm mixing up stuff now, but yeah, it's very difficult to do that. But the cloud sort of opens up those doors, but it can still be secure, right? I guess that's the thing, because people think cloud equals not secure, when in reality it can be very, very different. I mean, Siemens, for example, and other companies around the world have incredibly robust, measures in place to protect, data, for example.
I would even say this cloud equals not secure is a big misconception. And I think this example of money is a very good one for that as well. Saying if someone broke into your apartment and took all your money underneath your pillow, you probably have some insurance for that. I'm not quite sure, but it would be all gone, and the treatment of it or how to solve it would be on your desk. Compared to cloud, if someone stole money from your bank account, there's actually a bank that's taking care of that. So that's what you also pay for. when it comes to, I don't know, fees that the bank is putting towards you, but that's also the benefit you get out of it. And the same accounts for cloud data storage. Once, for example, just imagine you have a facility and you have all your data stored in local servers and your servers break down. That's also like equipment failure, but on a very different level, and all your data is going to be gone. For example, if you have it stored in a cloud, comparison to that, and one of the servers breaks down, there's a lot of security mechanisms that the cloud provider is taking care of that actually save your data from being gone. So that's also a big, I would say it's a big misconception that cloud is more insecure. I would actually rather say on-site is less secure. Well, okay, there's pros and cons for both sides, but cloud is also always a good solution.
Yeah, no, exactly. It's a misconception, probably more than a buzzword. But I think it's important it's a question that's still coming up today, and will probably continue to come up until people have fully shifted their mindset around that word and maybe disassociate it slightly, because in terms of Senseye, it's crucial to it, to the scalability and then ultimately the value you get from in our particular case. So I guess in terms of other buzzwords, so I wanted to cover sort of one more before we finish, and it's one that I'm not actually that I don't have a lot of knowledge on, to be honest, and it's one of these things that looks really cool as well, but I just don't have the knowledge, and it's digital twins. So again, maybe Maria, you could explain the concept of digital twins and maybe ground it in a little bit of reality. Because I guess, again, from my perspective, I'd probably say it's something like really futuristic and you can't touch it kind of thing. But you might disagree with that maybe and bring me back down to reality again.
I personally really like digital twins. Maybe to just give a definition first of what it means. It actually is just a virtual model of a physical asset. So it's a digital representation of something that is existing or could be existing in the future as a physical thing. This can be machines, this can be equipment, this can be rooms, this can be ships, this can be anything. Like anything that can imagine being a physical asset can also be a virtual model of it. And the great benefit we have with digital twins is actually we are able to simulate the behavior of the equipment, and we can actually predict and see how it will perform under different circumstances without even having to build it first. And that's a big advantage, and this actually saves a lot of time, effort, resource, and mistakes. So this is maybe a very great example. My background is actually from shipping. So I was working in the new build department of a cruise ship company for quite some time. And it is, you can't imagine how much effort it takes to build a new cruise ship. It's huge. It has so many factors being included when it comes to mechanical stuff, but also when it comes to interior design, all those topics. And you can make so many mistakes. And you can learn from your mistakes, but it takes a lot of time, and you really have to do a lessons learned after each new build vessel. And actually now imagine you would have had a digital twin of that whole vessel where you can plan ahead, where you can see, hey, okay, we actually built a tree in front of a door inside the vessel. You could see it in the digital model without actually building it in the physical one. So failure prevention is actually a big topic when it comes to digital twins. But also, and this is what is also being done in the shipping industry, they're actually simulating the vessel's behavior. So that's the basic thing a ship needs to be able to do, is to swim. And if you have a lot of volume and a lot of things planned on top of a vessel, for example, a swimming pool or 5,000 people walking across the vessel, you actually have to calculate, is that thing swimming in any way? And is it swimming under this and that circumstances, if there's a lot of wind, if there's a lot of waves, and all these things are actually simulated with a digital twin before the vessel is even started to be built, to see, okay, do the calculations all those topics make sense? Is the equipment done in a good way, the way it is planned to actually survive in the real environment? And this is the great benefit of digital twins. You save a lot of time and money by just trying it out in a virtual way first.
And I guess from my own understanding as well, like how does it compare, compare or work alongside predictive maintenance or work with predictive maintenance? So, yeah.
So it actually is a use case. The digital twin can actually help with predictive maintenance. That's the way I'd put it. For example, if you now speaking in machines, just if you run a machine that you've never run before, and you have, for example, new tools installed, new gear, whatever, and you want to try it out, you could try it out in a physical way, and you could try it out until it fails because you don't have enough knowledge and data yet. Or, and this is where predictive maintenance comes into play, you can also try it out via a digital twin. And digital twin is actually the predictive maintenance for the real asset, saying, okay, if we do it that way for 1 hour, it will break. So it actually predicts the maintenance before it even happens. And this is the same that you can do with digital twin, yeah.
Yeah, when you put it like that's pretty mad. And to what you were talking about before with your sort of ship example as well, it's almost like you could do a lessons learned before the project, actually, before the completion of the build, right? Which is just extraordinary, really, if you think of it like that.
Yeah, so most of the times what we were doing when we finished a vessel, we would do the lessons learned afterwards and try to not do it for the second one. But if you think about digital twin, you can actually do the lessons learned while doing it, while planning it, like preponing the lessons learned into let's learn first.
That makes it, yeah, and that makes a lot of sense, of course. Yeah, it does, it really does. But yeah, I think so. Again, I'm always saying that time flies on this podcast. And we've flown through a lot of buzzwords. Have we, from your point of view, Maria? Is there any missing, or is there any sort of, I guess, just to sort of round it off, is there any that you think people should really focus their attention on in terms of how it's really going to impact their sort of future and planning and digital transformation journey, let's say?
I would say we've covered a lot of topics. I would try to summarize it in a very brief way at the moment. So when we're talking about predictive maintenance, it all starts with data. It starts with data that's collected at the shop floor sites, for example, via IoT, so Internet of Things, sensors. So really collecting everything that is there from the machines running. And what we can do with that, and this is where the buzzwords all come into play, is real-time data analytics, having a look at what is really happening at the same time we're looking at it by using the big data, the big amounts of data that are actually produced and collected. And the key word here is getting insights and making use and value out of what we collect. And this is what is being done, for example, with machine learning algorithms. So algorithms that try to understand the data, and condition monitoring being the action of monitoring the data that is monitoring whatever is happening, changes, deteriorations, and with that action of condition monitoring, again, feeding artificial intelligence algorithms to predict topics, predict failures, predict whatever is there to be predicted, instead of relying on fixed schedules, instead of relying on or waiting for equipment to fail. Actually start with predicting what could be and provide insights and learnings before they even happen. And this is the great thing, the great benefit where it all falls into play. This is also where digital twins as a use case come into play, saying, hey, let's bring all these topics together. Let's try to get better. Let's try to get more efficient with our resources, with our time, with our money. And this is the big value, and the really big added value that you can create with predictive maintenance as a full story.
Fantastic. Yeah, very well summarized, because I gave you a lot to sort of summarize there, because we basically talked about everything to do with, well, a vast majority of digital transformation topics. So I think you did very well to summarize that, Maria. But But yeah, no, thank you. Thank you so much for taking us through it. I've sort of learned a lot. Like I said, I love the sort of comparisons and things to everyday life, which sort of helps me as a non-techie to understand it as well. So that's great. And I'm sure the audience took a lot away as well. So yeah, thank you, Maria, for your time today. And I guess thank you, everyone out there, for listening as well. And we look forward to seeing you on the next episode.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.